if a curve cuts every member of given family of curves at right angles, then that is called orthogonal trajectory. Right angle means alpha is equal to the 90 degrees. So if alpha not equal to 90 degrees, then the trajectory is called oblique trajectory. Here it is oblique trajectory, and alpha is equal to 90 degrees. This is called orthogonal trajectory. Orthogonal trajectory. Now, for example, if we consider a system of circles, system of concentric circles. I am taking XY plane, X axis, Y axis. This is X dash and Y dash. And this is the origin, center. At origin, we are taking one circle and another circle and another circle. These are the system of circles, system of concentric circles. If you take straight lines, so the straight line cuts the every circle. So this straight line cuts the every member of family of curves. So the straight lines are called orthogonal trajectories for the circles. Okay. So these are the orthogonal trajectories. So we have to see the procedure how to find orthogonal trajectory. There are two procedures for Cartesian coordinates. Cartesian coordinates, we have one procedure, and for polar coordinates, we have another procedure. First, in first step, we have to consider the given equation. First, we write the given equation. We see the in Cartesian coordinates, we have to consider in step 1, we have to consider given equation and identify the arbitrary constant. Identify the arbitrary constant in the step 1. Arbitrary constant. It is also applicable in polar coordinates. Okay. In step 2, differentiate the given equation. Sir? Yes. Differentiate with respect to x.
Voice break out, sir.
Now voice break out. Yes.
No, sir, it's clear, sir. No, sir.
Okay. Now differentiate equation 1 or given equation with respect to x. Here, in the step 2 in polar coordinates, differentiate the given equation with respect to theta, with respect to theta. And here, after differentiating with respect to x and eliminate the arbitrary constant. Eliminate constant. Simply arbitrary constant. Here also eliminate arbitrary constant. Okay. And after eliminating arbitrary constant, replace dy by dx by minus dx by dy. After eliminating arbitrary constant, replace dy by dx by minus dx by dy. Here, replace. Sorry, here we have to replace dr by d theta by minus r square d theta by dr. Okay, and integration. By integration, we get the required orthogonal trajectory. Okay, here also by integration, we get the required orthogonal trajectory. Okay, this is the procedure for finding orthogonal trajectories in Cartesian coordinates as well as in polar coordinates. Once again, in Cartesian coordinates, we have to take the given equation and identify the arbitrary constant. And in step 2, we have to differentiate the given equation with respect to x and eliminate the arbitrary constant. After eliminating arbitrary constant, replace dy by dx by minus dx by dy. After replacing dy by dx by dx by minus dx by dy, we have to integrate, we get the required orthogonal trajectories of family of curves. In polar coordinates, first to write the given equation and identify the arbitrary constant. And the second step, we have to differentiate the given equation with respect to theta and eliminate the arbitrary constant. Here in this case, we have to replace dr by d theta by minus r square d theta by dr. After integration, we get the required solution. Okay, this is the procedure to find the orthogonal trajectories of family of curves. First, I am taking a simple example. Find the orthogonal trajectories. Find the orthogonal trajectories of family of straight lines straight lines. Y is equal to cx. Here c is the arbitrary constant. So first of all, we are write the given equation y is equal to cx, and here c is the arbitrary constant. Differentiate this with respect to x, we get to dy by dx is equal to c. So dy by dx is equal to, from equation y equal to cx, we can write c value as y by x. Here the arbitrary constant is eliminated. Now replace dy by dx by minus dx by dy. So here we get minus dx by dy is equal to y by x. So by separation of variables, we get minus x dx is equal to y dy. So we can write it as y dy plus or x dx is equal to 0. By integration, we get y square by 2 plus x square by 2 is equal to arbitrary constant c. That means x square plus y square is equal to arbitrary constant is c. We can write this as c square also. Okay, 2c square is nothing but c square. So for the family of straight lines, the orthogonal trajectory is family of circuits. Okay, family of circuits. Now I am taking one problem from jail. The orthogonal trajectories. The orthogonal trajectories of the family of x square minus y square is equal to c given by. Now we have four options. xy is equal to c. Second option, x square plus y square is equal to c. And the third option, y is equal to c. And the fourth option, x is equal to c. These are the four options. First of all, add the given equation, that is x square minus y square equal to c, where c is the arbitrary constant. So differentiate this with respect to x. We get to 2x minus 2y dy by dx is equal to 0. So we can write x minus y dy by dx is equal to 0. Here it is, the arbitrary constant already eliminated. So just replace dy by dx by minus dx by dy. That means x minus y into minus dx by d is equal to 0. So we get x plus y dx by dy is equal to 0. From this we can write x is equal to minus dx by dy or dy by y plus dx by x is equal to some is equal to 0. So integrate on both sides, we'll get log y plus log x is equal to arbitrary constant c. So this is log yx or xy is equal to log c. So xy is equal to c is the solution. So first option is the right option. Okay. Now take another problem from DL. The orthogonal trajectories, the orthogonal trajectories of ay square is equal to bx square. Ay square is equal to bx square is first option. 2x square plus ay square is equal to c. Second option, 2x cube plus 3y square is equal to c. Third option, y square plus 2x cube is equal to c. And the fourth option, x square plus y square is equal to c. Okay. Here, a and b are two arbitrary constants. So first of all, we are differentiate the given equation with respect to x. So we get to 2a y dy by dx is equal to 2bx. Here 2 will be cancelled. And we can write a by b is equal to x by y into dx by dy. And from this equation, we can write a by b is equal to x square by y square. So equating the a by b values here. So we get x by y dx by dy is equal to x square by y square. So 1x, 1y is cancelled. So dx by dy is equal to x by y. Now replace dy by dx by minus dx by dy. That means here we get to minus dy by dx is equal to x by y. Now by cross multiplication, our variables available, minus y dy is equal to x dx, that is x dx plus y dy is equal to 0. By integration, we get x squared by 2 plus y squared by 2 is equal to arbitrary constant c. Therefore, the x squared plus y squared is equal to c is the required orthogonal trajectory. That is, fourth option is the right option. Now, I'm taking another example. It is also a DL question. The orthogonal trajectories, of y square is equal to 4ax is first option, y square by 2 plus x square is equal to c. Second option, y square plus x square by 2 is equal to c. Third option, y square minus x square is equal to c. And fourth option, y square plus x square is equal to c. So here the arbitrary constant is a. So first to differentiate the given equation, we get to 2y dy by dx is equal to 4a. So 2y dy by dx is equal to 4a. From equation this we can write y square by x. So 1y will be cancelled. Here it is arbitrary constant is eliminated. So replace dy by dx by minus dx by dy. That is minus 2 dx by dy is equal to y by x. So minus 2x into dx is equal to y into dy. Now integrate. We get now we can write it as 2x dx plus y dy is equal to 0. We are taking this is inside. So integration of this we will get to x square, here y square by 2 is equal to arbitrary constant AC. So y square by 2 plus x square is equal to C is the right option. Okay. And a very recent Gurukulam DL question. The orthogonal trajectories of the family of curves x power 4 by 3 plus y power 4 by 3 is equal to a power 4 by 3 or first option x power 2 by 3 minus y power 2 by 3 is equal to k power 2 by 3. Second option x minus y is equal to k, and third option x power 4 by 3 minus y power 4 by 3 is equal to k power 4 by 3. And fourth option x power 1 by 3 minus y power 1 by 3 is equal to k power 1 by 3. That is four options. First, see the given equation. Here a is itself an arbitrary constant. So differentiate this with respect to x. So we get 4 by 3 into x power 4 by 3 minus 1. That is 1 by 3 plus 4 by 3 y power 1 by 3 into dy by dx is equal to 0. So 4 by 3 answer. So x power 1 by 3 plus y power 1 by 3 dy by dx is equal to 0. So x power 1 by 3 plus y power 1 by 3. Now replace dy by dx by minus dx by dt. Minus dx by dt is equal to 0. So we get x power 1 by 3 is equal to y power 1 by 3 dx by dt. So this can be written as dy by y power 1 by 3 is equal to dx by x power 1 by 3. That is y power minus 1 by 3 dy is equal to x power minus 1 by 3 dx. So integrate this. And now integration of x power minus 1 by 3 is x power minus 1 by 3 plus 1. That is 2 by 3 minus, we are taking in powers in this can be written as x power minus 1 by 3 dx minus y power minus 1 by 3 dy is equal to 0. So integration of y power minus 1 by 3, that is x power y power 2 by 3 is equal to arbitrary constant. We can take k power 2 by 3. Okay, it may be k power c or it may be k power 2 by 3. So first option is the right option. Okay. Now I am taking one problem from recent Gurukul J. The orthogonal trajectories. Okay, before going to discuss this problem, I'm taking one simple example in polar coordinates. Find the orthogonal trajectory. Orthogonal trajectories of R is equal to 2a cos theta. Okay, where R and theta are polar coordinates. First, we have to identify the arbitrary constant, that is 2a. Okay, a is the arbitrary constant. Now, differentiate this with respect to theta. So we get dr by d theta, that is equal to 2a constant cos theta differentiation minus theta. And this is equal to 2a is equal to, we can write r by cos theta from the given equation. So this is minus sin theta as is. This is nothing but minus r tan theta. So this is the value of dr by d theta. Now we have to replace dr by d theta by minus r square d theta by. Now the left hand side is minus r square d theta by dr is equal to the right hand side minus r tan theta. One r will be cancelled, so minus also cancel. D theta by tan theta. We are separating the variables. 1 by r into r. Now d theta by tan theta become cot theta into d theta, that is equal to 1 by r. Now integrate on both sides. So cot theta integration log sin theta, that is equal to 1 by r integration log r, and arbitrary constant is log c. So sin theta is equal to CR, okay, log mn, log cancelling. Okay. So R is equal to, we can write 1 by sin theta. So R is equal to 1 by C is the arbitrary constant. So we can take it as UB, okay, for our convenience. So for R is equal to 2a cos theta, the orthogonal trajectory is R is equal to 2b sin theta. Okay. For R is equal to 2b sin theta, the orthogonal trajectory is R is equal to 2a cos theta. Okay. Now I am taking one problem, recent Gurukul JL question. Sorry, DL, Gurukul DL question. The orthogonal trajectory, the orthogonal trajectories of the family of curves. R is equal to, I am writing here, R is equal to K into sec 2 theta plus tan 2 theta R. First option, R is equal to C into e to the power of 2 cos 2 theta. Second option, R is equal to C into e to the power of minus cos 2 theta. And third option, R is equal to C e to the power of minus sin 2 theta by 4. And fourth option, R is equal to c e power minus sine 2 theta by 2. Okay. Now, clearly it is in polar coordinates. So, and k is the arbitrary constant. First of all, we have to differentiate this equation with respect to theta. So, we get dr by d theta is equal to k into sec 2 theta differentiation to sec theta into tan 2 theta and tan 2 theta differentiation to secant square 2 theta. And dr by d theta is equal to, I am eliminating the arbitrary constant from the given equation. We can write k is equal to r by this. So r divided by sec 2 theta plus tan 2 theta. Okay. Now we can take the numerator. We can take 2 sec 2 theta as common. So remaining tan 2 theta plus sec 2 theta. So tan 2 theta, sec 2 theta will be cancelled. So dr by d theta is equal to 2r sec. Dr by d theta is equal to 2r sec 2 theta. Now our target completed. K is eliminated. So replace dr by d theta by minus r square d theta by dr. That is minus r square d theta by dr. I'm writing. That is equal to 2r secant. Here one r will be cancelled. Now separating the variables here. D theta by minus d theta by sec 2 theta is equal to 1 by r into dr. 1 by r into dr. Here minus, I am taking minus here and 2 here. Okay. So 1 by 2 into 1 by secant means cos theta d theta is equal to minus 1 by r dr. Now integrate on both sides. So integration of cos 2 theta, that is sine 2 theta by 2, that is equal to minus 1 by r integration log r, the arbitrary constant is c. So here sine 2 theta by 4 is equal to log c by r, log m minus log n. So from this we can write c by r is equal to exponential of sine 2 theta whole divided by 4. Okay. Now we can take the reciprocal. So r by c is equal to 1 by e to the power of sine 2 theta divided by 4. So r is equal to c into, take to numerator. So we get e to the power of minus sine 2 theta by 4. Okay. This is the required orthogonal triangle. That is the third option is the right option. Okay. Now, these are the problems related to orthogonal trajectories. The కొన్ని problems ఉన్నాయండి, simple problems. You can compare and try చేస్తాను. Okay. ఒక క్వశ్చన్ అడుగుతున్నాడు కాబట్టి చెప్పడం. Okay, clear అండి orthogonal trajectory? Any question from this? I have a question. I'm taking different problems. Anyone? Please ask me any question from orthogonal. Yes. No questions. Okay, I will continue the next topic, that is linear differential equations with the constant coefficients. Linear differential equations with the constant coefficients. Constants coefficients. Okay, from this we have 3 or 4 questions. The variation of parameters వస్తుంది, Cauchy Euler equation కూడా వస్తుంది. ఇవన్నీ యాడ్ చేసుకొని మనకు 3 to 4 క్వశ్చన్స్ అడుగుతున్నాడు. సెట్ లో కూడా 2 క్వశ్చన్స్ అడుగుతుంది. సెట్ కాబట్టి it is an important topic. Okay. First of all, you have to see the differential equation form. The differential equation of the form an d power n y by dx power n plus an minus 1 d power n minus 1 y by dx power n minus 1 plus and so on plus a1 dy by dx plus a naught into y is equal to qx, where an minus 1, a1, a0 are constants. an minus 1 and so on, a1, comma, a0 are constants. This type of differential equation is called the linear differential equation with the constant coefficients of order n. Okay. Now, for this differential equation, we can use the notation d is equal to d by dx. So that d square is equal to d square by dx square and so on. D power n is equal to d power n by dx power n. So the given equation become an d power n plus an minus 1 d power n minus 1 plus and so on a1 d plus a naught into, you can take y as common. That is equal to log x. This is the simplest form, notation form or operator form of the given differential equation. So, if q of x is equal to 0, q of x is equal to 0, this differential equation is called linear differential equation with the constant coefficients, homogeneous linear differential equation with constant coefficients. If q of x is not equal to 0, then this is called non-homogeneous linear differential equation with the constant coefficients. Okay. Now, for this differential equation, the solution is of the form y is equal to yc plus yp, or we can write yc as cf and yp as pn. That is y is equal to cf plus pn. Here cf means complementary function. Complementary function. Sometimes it is also denoted by yc, and pi means particular integer. Okay. The general solution of this equation is y equal to complementary function plus particular integer. Okay. For homogeneous linear differential equations, the solution become only complementary function. Y is equal to cf only. U of x equal to 0 కాబట్టి outside term ఏముండదు, 0 కాబట్టి only complementary function is the general solution. If q of x is equal to some value e to the power of x or sin x or x into e power x, okay, like that ఏదైనా ఫంక్షన్ ఉందనుకోండి, we need to find a particular integral and add them, we'll get the required solution. Okay. Now we have some methods or some rules to find the complementary function. Okay. I'm taking the given differential equation. that is, I'm taking second order differential, whatever the equation, that is an d power n plus an minus 1 d power n minus 1 plus and so on a1 d plus a naught into y is equal to 0. To find the complementary function, we have to take the corresponding homogeneous linear differential equation. Corresponding homogeneous linear differential equation. For this differential equation, we have to write the auxiliary equation. Write the auxiliary equation. It is called helping equation. So to write the, after writing the auxiliary equation, we can find the roots. The auxiliary equation just replace d by m. Just replace d by m. So we get a equation of the form an m power n plus an minus 1 m power n minus 1 plus and so on plus a1 into m plus a naught is equal to c. This is the auxiliary equation. Okay. For example, I am taking one differential equation, d square minus 2d plus 5 into y is equal to e to the power of x. I'm saying e to the power of 2x. I'm taking second order linear differential equation with constant coefficients. To find this differential equation, as the solution of the form y is equal to complementary function plus particular derivative. To find the complementary function, we have to take the corresponding homogeneous equation. That is d square minus 2d plus 5 into y is equal to 0. Now, for this differential equation, we consider the auxiliary equation. Auxiliary equation. The auxiliary equation just replace d by m. That is m square minus 2m plus 5 equal to 0. Okay. Now, this is a quadratic equation. This is a quadratic equation. So we have two roots. Okay. Now we have two roots. According to nature of the roots, we have to write the complementary function. Okay. First, I am giving some nature of the roots and corresponding complementary function. First of all, I am taking only one root, one real root, say m1, only one root. Then the corresponding complementary function CF is equal to, we can write C1 e to the power of C1 e to the power of m1x for one real root m1. For two real roots, two real and different roots, real and different roots, say m1 comma m2. Then the corresponding complementary function, that is CF or YC, sometimes we can add YC, that is C1 e to the power of m1x plus C2 e to the power of m2x. Okay, and so on. If we take three roots m1, m2, m3, these are all distinct, they are different. Then the complementary function is C1 e to the power of m1x plus C2 e to the power of m2x plus C3 e to the power of m3x. Like that, we can have more than any roots. One root is C1 e to the power of m1x, two roots C1 e to the power of m1x plus C2 e to the power of m2x. For three roots like this, we can take four roots distinct. So yc equal to C1 e power m1x plus C2 e to the power of m2x plus C3 e to the power of m3x. We can add C4 e to the power of m4x like that. If the roots are two roots, for example, m1 comma m2, they are repeated or equal. these two roots are equal. That means m1 is equal to m2. Say that common value as m. Okay. So we can write the complementary function yc as c1 plus c2 x into e to the power of mx. Okay, two repeated roots. If we have three repeated roots, three repeated real roots, that is m1, m2, m3 are repeated, and the common value if you take m. Okay. So the complementary function yc is equal to, we can write c1 plus c2 x plus c3 x square into e to the power of mx. Okay, like that we can write for four repeated roots, that is m1, m2, m3, m4. The common value is say m. So we can write yc is equal to c1 plus c2 x plus c3 x square plus c4 x power 3 e to the power of mx. Okay. సరే జేఎల్లో ఇదే క్వశ్చన్ మీద అడిగాడు. క్వశ్చన్ ఎలా అడిగాడంటే ఇక్కడే చెప్పేస్తాను. m1 comma m2 comma and so on mn are repeated roots. Say m. Okay. So the complementary function, different options ఇచ్చాడు ఇక్కడ. mn n repeated roots అంటే two repeated roots ఉన్నప్పుడు c1 plus c2 x power 2 minus 1. This is 1 means 2 minus 1. 3 repeated roots ఉన్నప్పుడు 3 minus 1. 4 repeated roots ఉన్నప్పుడు 4 minus 1. కాబట్టి n repeated roots ఉన్నప్పుడు ఎలా వస్తుందంటే yc is equal to c1 plus c2 x plus c3 x square. So it is x square here. Plus and so on cn x power n minus 1 into e to the power of x. Okay, different options ఉన్నాయి. This is the right option. And if two roots are complex numbers, for example, I am taking complex numbers. This alpha plus or minus ib. Then the corresponding complementary function is yc is equal to e to the power of alpha x into c1 cos beta x plus c2 sin beta x. This is the corresponding complementary function. Okay. Sometimes the complex roots are repeated. For example, alpha plus or minus I beta is repeated. Alpha plus or minus I beta. The complementary function yc is equal to, we can write e to the power of alpha x into c1 plus c2 x into cos beta x plus c3 plus c4 x into sin beta x. This is the corresponding complementary function. If the roots are one pair of sets, that is like this, alpha plus or minus root beta, alpha plus or minus root beta, then the corresponding complementary function yc is equal to e to the power of alpha x into c1 cos hyperbolic x root beta plus c2 sin hyperbolic x root beta. This is the corresponding complementary function. The sets are repeated. It is alpha plus or minus root beta and alpha plus or minus root beta. Then the corresponding complementary function is e to the power of alpha x into c1 plus c2 x into cos hyperbolic x root beta plus C3 plus C4 x into sine hyperbolic x root beta. These are the rules to write the complementary function. Okay. Real roots, complex roots, real roots repeated, distinct ఉన్నప్పుడు different, complex roots two complex roots ఉన్నప్పుడు ఎలా repeated complex roots ఉన్నప్పుడు ఎలా నెక్స్ట్ సర్ట్స్ ఉన్నప్పుడు ఎలా అనేది కాబట్టి you have to remember these 10 notation formulas. Okay. Now we see some problems related to complementary function. Okay. First, I am taking one problem from DL, recent DL. The general solution of the general solution of d cube, sorry, d square y by dx square plus dy by dx plus y is equal to 0 is. Then options different ఉన్నాయండి. Direct problems చేస్తున్నా. It is from D. First write the operator form, that is d square plus d plus 1 into y is equal to 0. So the corresponding auxiliary equation. Just to replace d by m. That is m square plus m plus 1 is equal to 0. This is a quadratic equation. We can factorize by using minus p plus or minus under root of d square minus 4ac by 2f. So m is equal to minus 1 plus or minus 1 whole square d square minus 4 into a into c, 4 into 1 into divided by 2. That is equal to minus 1 plus or minus under root of, this is 1 minus 4, that is minus 3 by 2. This is equal to minus 1 plus or minus root of minus 1 is I by 2. So here the roots are complex numbers. Alpha equal to minus 1 by 2 and beta is equal to 3 by 2. So the complementary function. Therefore, yc is equal to e to the power of minus 1 by 2 x into c1 cos root 3 by 2 x cos beta x plus c2 sin beta x sin root 3 by 2. Okay. So as we know that this is the homogeneous linear differential equation with constant coefficients. So the general solution is y is equal to yc only. No need to find yp. When it is q of x is equal to 0, not equal to 0, no need to find yc. Therefore, y is equal to yc. That is e to the power of minus 1 by 2x, c1 cos root 3 by 2x plus c2 sin root 3 by 2x is the general solution of the given differential equation. And I am taking one more problem. The solution of d cube plus d square plus 4d plus 4 into y is equal to 0 is. Just we need to find a complementary function. First of all, I am writing the auxiliary equation, that is mq plus m square plus 4m plus 4 is equal to 0. Here it is a cubic equation. We have three factors. First, m equal to -1 satisfies. So m plus 1 is a factor. We can find the remaining factors by synthesis. So take m is equal to -1. We add the coefficients 1, 1, 4, 4, and take 0 here. Now add them 1, -1, 0, 0, 4. It is -4. This is 0. So the quadratic equation become m square plus 4 equal to 0. So m square equal to -4. It is m is equal to plus or minus 12. Here the roots are m is equal to -1 is the real root. M is equal to plus or minus 2i. It is nothing but 0 plus or minus 2i. These are complex roots. So we can add them. So the general solution is y is equal to yc. So y is equal to yc means c1 e to the power of -1x per real root. And here alpha equal to 0, beta is equal to 2. That is e power 0x into c1 cos, c1 is completed. So c2 cos 2x plus c3 sin 2x. So this is nothing but e to the power of -x plus c2 cos 2x plus c3 sin 2x. This is the general solution of the given equation. Okay, here one real and another one is complex. I am taking one problem, next problem, that is also real. The complementary function of d plus 1 into d minus 2 whole square into y is equal to e to the power of x. Okay. ఇక్కడ మనల్ని జనరల్ సొల్యూషన్ ఫైండ్ అవుట్ చేయమని అడగలేదు, జస్ట్ కాంప్లిమెంటరీ ఫంక్షన్ ఫైండ్ అవుట్ చేయండి. So for complementary function, we have to take the corresponding homogeneous equation. D plus 1 into d minus 2 whole square into y equal to 0, and add the auxiliary equation. The auxiliary equation is m plus 1 into m minus 2 whole square equal to 0. So here m is equal to -1, m minus 2 whole square 0 means m equal to 2 common. So here 2 repeated twice and -1 is different from 2. So the complementary function Cm or Yc is equal to C1 e power -x. ఇక్కడ వరకు ఇది సపరేట్ ఉంది, ఇది రిపీట్ అయినాయి కాబట్టి C2 plus C3 x into e to the power of 2x. Okay. Now one more problem, that is the solution of the differential equation d square y by dx square plus minus 4 into dy by dx plus 4 into y is equal to 0 is. Okay, different options in that. It would a DL question, I think. So write the operator form. d square minus 4t plus 4 into y is equal to 0. Now the corresponding auxiliary equation m square minus 4m plus 4 equal to 0. So this can be written as m minus 2 whole square equal to 0. M is equal to 2 comma. So here two real roots are repeated. So the general solution y equal to yc complementary function. Here roots are repeated. So c1 plus c2x into e to the power of 2x is the general solution of the given equation. Okay. So the problems ఉన్నాయండి నేను మీకు పంపిస్తాను నేను డిఫరెంట్ గా ఉండే ప్రాబ్లమ్స్ అంటే నేను చెప్తాను in tomorrow class I will try to discuss the particular